Okay, this is AP AB and BC Calculus. We are doing Unit 3, Section 3, which is differentiating inverse functions. So this sort of boils down to one formula that is worth knowing and will probably be a single multiple choice on your AP or a single part of a multi-step free response. So the derivative of an inverse function, let's call g of x f inverse of x, meaning that just for the simplicity of notation, g is the inverse of f. G prime of a then is 1 over f prime of g of a. You'll also sometimes see it in the significantly less simple form where we use f inverse. So f inverse prime of a is equal to 1 over f prime of f inverse of a, which is a lot. So let's actually kind of walk through what this is going to look like. We're going to do a bunch of examples in a couple different ways, some with equations, some with tables, etc. All right, so we're going to go ahead and say that g is the inverse function of f, and we're given some values. We're told that f of 4 rather is equal to 2, f of 1 is equal to 4, f prime of 1 is equal to negative 6, and f prime of 4 is equal to 7, and we're asked to find g prime of 4. So here's the thing about this problem, right? The first thing you're going to have to do is recall the formula, right? So the formula is that g prime of 4 is 1 over f prime of g of 4. So step 1 is recall. If you don't remember the formula, you're kind of stuck, right? Dead in the water, won't be able to do anything. So step 1, recall. Step 2 is to figure out how on earth you're going to figure out g of 4. So the question is, g of 4 equals some mystery value, meaning that g has the point 4 comma blank. Well, the way inverse functions work, because f and g are inverses, if g has the point 4 comma blank, then f has the point blank comma 4. And right there, that's the trick. Because f does have a point that's blank comma 4, f has the point that f of 1 equals 4. Meaning that that mystery number I'm trying to find for g must be a 1, right? Because essentially the way inverse functions work is they swap the x's and the y's. So if we know g of 4 is some mystery number, we can look at f and say, oh, f of some mystery number must be 4. Once I know g of 4 is 1, now it's just a matter of working backwards, right? So I have 1 over f prime of my g of 4 is now a 1. Then I look at the list of information I was given. I was given what f prime of 1 is, so that's a 1 over a negative 6, okay? So the first thing I have to do, right, is find that slope, which is what I was asked to evaluate g prime of 4, and there you have it, it's negative 1/6. In part B, I'm asked to give the equation of a tangent line, right? So anytime you're asked to give an equation of a line, you need two things, right? You need a point, right? And notice that it's a g of x point because I'm tangential to g. Well, I need the point where I plug in 4. Well, we've already established that that point is 4 comma 1 because we needed that to figure out this first piece of information, right? And then the second thing I need is I need that tangent slope. Well, my tangent slope should be g prime of 4, which we already found in part A to be a negative 1/6. So basically in part B, what I'm asking you to do is put together two pieces of information that you already needed to figure out A. Y minus the y value equals negative 1/6, the quantity x minus 4. If you wanted to solve for y, I would suggest that you do it by just adding that y to the, or adding that 1 to the end, right? It's not worth cleaning this up and having fractions. All right, let's go ahead and do a P1. Same situation. So again, the very first step here is to have that recall to say that you know what this formula is. If you don't know the formula, you're not going to get this question right. So g prime of negative 2 is 1 over f prime of g of negative 2, right? Once I recall the formula, then I have to say, cool, my next job is to figure out what g of negative 2 is, right? So g of negative 2 is some mystery number that I don't know, right? Meaning that g has the point negative 2 comma question mark. Well, because of the way inverse functions work, right, that means that f has the point question mark comma negative 2, right? So that has to be a point for f of x. So I look and say, when is f of x equal to a negative 2? Oh, there you have it. It's a 7. So once I know that this is a 7, I can realize that that's the output of the g function, right? The input of the f function is the output of the g function. So I get that this is 1 over f prime of 7, right? And then I look for f prime of 7, and there it is. So I get 1 over 3, and that's my slope. So in part B, again, you're being asked to put together two pieces of information that you already have, right? So first we need a point. Well, we found that right here, we found that the point was -2 comma 7, right? That's my point, right, for g of x. The second thing I'm going to need is I'm going to need that tangent slope, but that tangent slope should be g prime of -2, which we already found in part A to be a 1/3. So you're just putting the pieces together. Y minus the y value equals that 1/3 in parentheses x plus a 2. If you wanted to solve for a y, you could add the 7 over. And that's it. All right, moving forward. E2. So again, we're in the situation where g is the inverse function of f, and I've given you select values of f and f prime. This is basically the same question I gave you before, but instead of writing it as a sentence where I just listed values, so if we go back here, I just listed values, now I'm presenting it to you as a table. This is a pretty common AP strategy, to give you information that you're used to and that you've seen before, but to give it to you in a different way than you've seen before to try and throw you off your game. So same exact set of information. So first step is to recognize that I need the formula for g prime of 8. That's going to be 1 over f prime of g of 8, right? So yet again, I find myself in this situation where my first job is to figure out what is g of 8. So if g of 8 is some value I don't know, that means that g, right, g has the point 8 comma question mark. Well, based on the way inverse functions work, that must mean that f has the point question mark comma 8. So I look at the table and say, okay, when does the f have an output that is 8? Well, sure enough, f of x is 8 when x is 3. So if f has the point 3, 8, then g has the point 8, 3. So g of 8 must be a 3. I get 1 over f prime of 3. And then I look and say, hey, is there an f prime of 3? Oh, look, there is. It's a 5, so that's a 1 over 5. All right, let's go ahead and do a P2. Same idea. You're going to find g prime of 1. Go ahead and pause me if you don't need me to do it, or if you just want to try on your own. So g prime of 1 is going to be an f prime of g of 1, right? Again, my first task then is to figure out what g of 1 is, right? So if I want g of 1 is some question mark, that means that f of that question mark has to give me 1. That's how inverse functions work. So I look for where there's an f output of 1, and sure enough, there's an f output of 1 at 8. So 8 comma 1 is a point for f, which means 1 comma 8 is the point I want for g. So I get 1 over f prime of 8, right? And then I look on my table, what's f prime of 8? Well, it's a -4, so it's a 1 over a -4. Cool, moving on. So now we'll do a couple with equations. All right, so f of x equals cosine x on the window from 0 to pi. So that's basically the top half of your unit circle, right? That's from here to here, okay? And we're going to call g the inverse of f, right? And we want to find g prime of -1/2. So again, the first thing you should do is copy what you know the formula should be, which is 1 over f prime of g of -1/2, right? Cool. So then the next thing you're going to have to do is you're going to have to figure out, cool, what is g of -1/2? Well, I know that g of -1/2 is this unknown that I need, right? That means that f of some unknown value should give me a -1/2. So the question is, when is the cosine of x equal to a -1/2? Well, I'm pretty sure that that's right here at 2 pi over 3. Once I realize that that happens when x is 2 pi over 3, that means that f, right, so f has the point 2 pi over 3 comma -1/2, which tells me that g has the point -1/2 comma 2 pi over 3. So this is a 2 pi over 3. Once I know that's a 2 pi over 3, I know that what I'm trying to find is 1 over f prime of 2 pi over 3. Well, this problem gets a little more difficult because right now I don't have a nice handy value for f prime. I actually have to find it. So I know that if f is the cosine, and let me erase to give myself a little bit of space. Okay, so I know that f is the cosine. So knowing that f of x is cosine of x, that means that f prime of x should be negative sine of x, which means that f prime of 2 pi over 3 is the negative sine of 2 pi over 3. So again, you really need to know your unit circle here. this is going to be a positive root 3 over 2, so it's a negative in front of that positive root 3 over 2, meaning that I get that this is a 1 over a negative root 3 over 2. You're going to not want to leave that as a fraction, right? So you're going to want to flip it over in general. That's not a wrong answer, but it's much more common that you're going to see this as a negative 2 over root 3. That's probably the most common answer. You certainly could choose to rationalize, right? If you multiplied the top and bottom both by root 3, you'd get negative 2 root 3 over 3, which is also totally okay. But that's the gist. So again, notice that knowing your unit circle is a thing that's going to be an issue. All right. P3, you're going to go ahead and give a try of the same skill set that we just did, right? So again, I want g prime of e squared. So the first thing you have to do is you have to regurgitate what that formula is, right? It's 1 over f prime of g of e squared, right? If you don't know the formula, you're kind of stuck, right? The second thing I need to do is I need to find what g of e squared is, right? So we're saying g of e squared is some mystery number I don't know. Well, that's saying f of some mystery number is an e squared. So since I have the formula for f, I say, okay, cool, e to the 4th is equal to e squared. That means 4x is equal to 2. My x must be a 1/2. So once I know that it's f of 1/2 equals e squared, I know that g of e squared must be a 1/2. Great. So now I'm at the point where I have 1 over f prime of 1/2. Awesome. But I still need f prime, right? All I have is the f function. I don't know f prime yet. So I'm going to go ahead and look at my f function. Oh, I tried to switch colors. There we go. So now I need f prime, right? So I know that f of x is e to the 4x. So f prime of x should be, the derivative of e to the stuff is e to the stuff, but then I have to do the chain rule, so I multiply by the derivative of 4x. So my f prime of 1/2 is going to be a 4 e to the 4 times 1/2, which would be 2, so I get 4e squared. So my answer ends up being a 1 over a 4e squared. All right, let's do an E4 and a P4, and then that'll be it for this section. So now we're going to go ahead and do one of these equation problems again, just like you saw in E3 and P3, but we're going to go ahead and find the tangent line, right? So tangent line to G, which is important, right? So as soon as I hear I want a tangent line, I need two things. I need a point, right? So I'm going to need 3 comma whatever G of 3 is, and we'll figure that out in a sec, right? So I have to figure out what G of 3 is. And the second thing is I need a slope, right? And my tangent slope is going to be G prime of 3, which is that same scale that we've been looking at. Once I have a point and a slope, I can write my answer in point slope, right? So hang on, get rid of this little box thing. There we go. All right, so let's go ahead and walk through this. So the first thing, I need the point anyway, and I also know that I'm going to need, when I'm asked to find G prime of 3, I know that G prime of 3 is going to be 1 over f prime of G of 3 anyway, right? So I'm going to need G of 3 either way we go about this, so I might as well start finding that G of 3 first, right? I need it for both things, so I might as well go ahead and find G of 3. So I know that G of 3 equals blank means that f of some blank equals 3. Well, f is the natural log of x, and it's supposed to equal 3. The way we get rid of a natural log is by exponentiating, so I'm going to get that x is e cubed. Once I know that that's the x value, so once I know that, I can say, okay, cool, it's not G of 3 anymore, it's now an e cubed. Great, right? So I can kind of work my way back up and say, cool, so f of, we're almost there. There we go, f of e cubed, there we go, equals 3, which is why we know G of 3 is e cubed. So I've got my point, great. Now I need my slope. So I'm at the point where I know that this is 1 over f prime of e cubed, right? So now I just need f prime, right? So the second skill set I'm going to need is I'm going to need to differentiate and find f prime. So f prime of x should be 1 over x, right? The derivative of natural log is 1 over the stuff, which means that f prime of e cubed should be a 1 over e cubed. Well, that means that my slope, if we come back here, is 1 over a 1 over e cubed, which is going to end up just being an e cubed. So that's my slope. And then that leads me to my tangent line. So my tangent line after all that work is y minus the y value equals my m, which also turns out to be an e cubed, x minus my x value. And if you want, you could add the e cubed over, but there you have it, right? And it's weird looking because I know you're not used to having e's as your slope or e's as your y value, but it is what it is. All right, you're going to go ahead and try P4, and then that'll be the end of this video. So same idea. Now, watch out, though, because I specifically said equation of the normal line, right? So you're going to have to find the tangent slope, but you're not going to use that. You're going to use the opposite reciprocal. Cool. So what that means is that we need a point, right? So I need that point, right? I'm going to need root 3 over 2 comma whatever g of root 3 over 2 is, which we're going to have to find, right? And I'm going to need a slope, but remember, it's the normal slope. So it's going to be the opposite reciprocal of g prime of root 3 over 2, right? So it's not g prime of root 3 over 2. It's going to be the opposite reciprocal of that because I said normal. So you're going to have to find tangent first and then flip slope, change sign. Okay, so let's go ahead and start with our g of root 3 over 2. So g of root 3 over 2 equals some blank space is the same thing as saying f of whatever that mystery value is root 3 over 2. So you're being asked, when is sine of x equal to root 3 over 2? And notice that the interval we're talking about is quadrant 1, right? You were given 0 to pi over 2. So the spot you want is this pi over 3 right here, right? So my x is going to be a pi over 3, which means that if I work backwards, g of root 3 over 2 is a pi over 3. So that's my point, right? Root 3 over 2 comma pi over 3. The next thing I'm going to need is I'm going to need an f prime, right? Because we know that g prime of root 3 over 2 should be 1 over f prime of g of root 3 over 2. Well, we just found g of root 3 over 2, right? It's a pi over 3, so this is 1 over f prime of pi over 3. So I need to know what pi over 3 is, right? So, I'm sorry, what f prime is. So f of x was sine of x. F prime of x is going to be cosine of x. So this is going to be a 1 over the cosine of pi over 3, which is a 1 over a 1/2, or a 2. So once I realize that 2 is my tangent slope, right? So this is my tangent slope. I don't want the tangent slope. I want the normal slope, right? Because it said normal line. So I recognize that my normal slope must be a negative 1/2, right? Because it's the opposite reciprocal of this 2 that we have right here. And I have the point root 3 over 2 comma pi over 3. So my answer is going to be y minus the y value equals my m, x minus the x value. And that's it. And if you want to add the pi over 3 over to the other side so that you've solved for y, you absolutely can. And that is our Unit 3, Section 3.